Okay, this is the first page of the linear programming project packet, and I'm going to go through each of these questions with you. Please be prepared for a group test on Thursday and Friday on this kind of material. It will be more difficult, and that's why you're allowed to work in a group, but this packet will get you ready for that. All right, so we're planning an advertising campaign, and if we let X be the TV ads and Y be the magazine ads, write an inequality for your advertising budget. All right, so it's going to be, of course, 600 times the TV ads plus 1,200 Y for the magazine ads. And because I have a budget of $9,000, all of that has to be less than or equal to the $9,000 budget. Okay? Then, number 2 gives us another constraint. Due to space limitation, the magazine publishers tell us we are only allowed to purchase up to 6 magazine ads. So again, if magazine ads are Y, then I can only purchase less than or equal to 6. Okay, and then with the television ads, we can only purchase up to 7. So then X is less than or equal to 7. So that's those first 3 inequalities that you need. Then if we scroll down to the bottom to number 4 and 5, now again, these constraints keep it to the first quadrant because we can't buy negative numbers of ads. So again, if TV ads are X, then X has to be greater than or equal to 0. And then with the magazine ads, Y is greater than or equal to 0. Okay, so that's everything on that first page. And then it tells us to graph them. So we're going to go on the second page and graph the system of inequalities that you found on the previous page. So first of all, if we are going to graph 600x plus 1200y is less than or equal to 9,000. Well, to be able to graph that, I've got to put it in a form that I can graph. Now, I know that the inequality is not going to flip here because B is positive. Therefore, I'm just going to use negative A over B for slope, which is going to be negative 600 over 1200. So that's going to be negative 1/2. And then I'm going to use C over B for my y-intercept. So that's going to be 9,000 over 1,200. And that's going to be, let's see, if we mark out some zeros, that's going to be 90 divided by 12. And I bet 90 will divide by 12. Maybe not. Divided by 12. That's 7.5. So my y-intercept is 7.5. Okay, so let's graph that. I graph my y-intercept first. And 1, 2, 3, 4, 5, 6, 7. All right, 1, 2, 3, 4, 5, 6, 7.5. 7.5 is going to be between 7 and 8, halfway between 7 and 8. And then I'm going to go down 1. Notice that's at the half. Down 1 over 1, 2. Down 1 over 1, 2. Down 1 over 1, 2. And so I'm just going to extend that line as far as I can. So that is going to be a solid line because it has equal to, and all of our lines have equal to. Now this one is less than, so it's going to shade below that line. So I'm just going to keep that in mind as I graph. Then if I am graphing y is less than or equal to 6, well, y is a horizontal line. So at 6, 1, 2, 3, 4, 5, 6, this is 6. So that's going to be a horizontal line through that point, and it's also going to shade below. Then x is less than or equal to 7. So that's going to be a vertical line through 7. 1, 2, 3, 4, 5, 6, 7. So a vertical line through 7, and that's going to shade less than as well. So I'm just using these arrows to kind of see where my constraints are going to be. Okay, where my shaded in area. And then, of course, X is greater than 0 and Y is greater than 0. Those are going to just confine it to the first quadrant. So these are going to be along the axes, the X and Y axes. And then, of course, those are going to shade greater than. So really, my area of shading is going to be this area here. Okay, so there's my area that I'm concerned with. All right, then it asks me, determine the 5 points where the graphs intersect. These are called vertices of the region of feasible solutions. That's a lot of vocabulary there. These are called the vertices of the region of feasible solutions. So each one is a vertex. So if I go through here, I can mark these vertices. I'm marking them kind of in a teal color here. And then we can identify these points. Of course, we have 0, 0. We have 7, 0. We have 7, 4 here. This one is 1, 2, 3, 6. And then that point is 0, 6. So those are the vertices of our feasible region, because again, our feasible region is in the purple that I colored in. Now, moving on to the next page, that is, and this feasible region will come back up later. So I'm going to screenshot this, so hopefully I can come back to this screen later. So hang on just a second. All right, got that screenshotted. Now let's move down, and so in that area is where you should have those 5 ordered pairs that I just gave you on the graph. So like 0, 0, 7, 0, 0, 6, 7, 4, 3, 6. Those will all go in numbers 1 through 5 there. All right, let's move on to the television ads. Now, follow the data. The following data was collected in the past years to try to determine how many TV ads affect CD sales. Plot the points and estimate the line of best fit. Okay, now notice that here they tell us to use these points to determine the line of fit. So you're going to plot all these points. Now I'm not going to plot all these for you. You know how to plot points. These are your X values, these are your Y values. So you see that it is going to start at the origin at 0, 0. And then it goes up over 5 and up to 725. Which is going to be right about there. And then it's, so they're not in order. They're all scrambled around, and so that's why it's a scatter plot. That's why you're not going to connect these as they are. So they ask us to use 150. So I'm going to put those in a different color because that way I know those are the ones we're going to use. 150. And 6, 900. So this is the line of fit, if I can get it straight. This is the line of fit that we're going to use. Okay, now you should have a whole bunch of other points on here because you need to graph all of these and then plot these 2 purple points that I just put in there. Okay, so make sure you've got all of those. You can do that after the video's over if you have to. Now, it says graph the line through the both points. I've done that. Find the slope of the line. Well, if we are given 2 points, we find slope using the slope formula. So slope is going to be 900 minus 150 over 6 minus 1. So that's going to be 900 minus 150. That's going to give me 750 in the numerator and going to give me 5 in the denominator. And then when I divide that out, that's going to give me a slope of 150. All right? Then write the equation of the line. Well, I need 2 things to write an equation of a line. I need the slope and I need the y-intercept. Well, luckily, this data had the y-intercept in it. Anytime I have an x value of 0, whatever the corresponding y is going to be my y-intercept. So in this case, it's going to be 0. Now, please do put these answers. I'm just doing this so I can see the graph all together. Write the equation of the line down there in number 7 where it says. So if my slope is 150, my y-intercept is 0, then the equation of my line is y equals 150x. Then number 8 says, what does the slope tell you about how each TV ad affects sales? Well, if the slope is 150, then what that says is for every TV ad, CD sales is increased by about 150. So for every TV ad that I put in for X, I'm going to get 150 CDs sold. So if I sold 3, so if I did 3 TV ads, then that would be 3 times 150 would give me the sales that would increase. All right. Now we're going to do the same thing for the magazine ads. Okay. So for the magazine ads, it's the same thing. You've got a scatter plot. You need to plot all of those points and then go back and use the 2 points that they gave you. Okay. They gave you 1 100 and 8 800. So your line of best fit should look like this. Then we find slope using those points. So we do 800 minus 100 over 8 minus 1. So that's 700 divided by 7. So my slope is 100. Now, in this case, I'm not given the y-intercept. So I don't know what that is. Now, I could assume that it's 0, 0. But I'm not 100% sure. So what I should use is my slope and one of the points. And I'm going to use 1 100 because that's the simplest point. So y equals 100 times x minus 1 plus 100. Now, I can see that that is going to work out that way. I'm going to distribute my 100. Y equals 100x minus 100 plus 100. So, of course, the hundreds cancel out and give me y equals 100x. So that is the equation. Now, that should tell us that for every magazine ad, CD sales should be increased by 100 because, again, our slope is our rate of change. Okay, so that completes the magazine ad page. Now, we have enough information to solve the linear program. Write an objective function for CD sales. Think about how each TV and magazine ad affects the sales. So, this is about how it affects the sales, not how much they cost. So, this is a little different. So, f of xy equals 150x plus 100y. So that is our objective function. So we've taken the equations and added them together because that's how they would both affect the total sales, because the TV ads are going to affect him one way and the magazine ads are going to affect him another way. All right, then we take that objective function and we use the vertex points. So here we'll use those vertices that we got on the second page. So that's where I'm getting these. These are those that I labeled in the graph on the first or second page. And I'm just copying these down here. Okay. Then we take the objective function and substitute those vertices in. So 150 times 0 plus 100 times 0 should give us a total sales increase of 0. Again, because if we're not placing the ads, then we're not going to get the increase. Then if we do 150 times 7 plus 100 times 0, then I should see a sales increase of 1,050, because 150 times 7 should be 1050 or 1,050 CD sales. And you just keep going down through here on these. I'm going to give you the answers. I'm not going to write them all out here in the objective function section. You need to write those out. I'm not going to, but I'll give you the answer on those. And that'll give me 600, 1,450, and then 1,050. Okay? Now, what is the maximum and where does it occur? Well, we can see where the maximum is. It occurs at the point 74. I don't know if you can see that highlight or not on the screen, but it's 1,450. Okay, and that occurs at the point 74. Knowing this information, how many TV ads and magazine ads should you buy? Well, I should buy, since X was my TV ads, then I should buy 7 TV ads and I should buy 4 magazine ads. Okay, so 7 TV ads and 4 magazine ads. Now there is an extra credit section, and you should work on that on your own. Try to come up with that, and I will answer any questions before I start the test on Thursday. Okay? So look at how this scenario would change the solution. Okay? That would be your classwork / homework.